Good morning, everybody. Welcome to a cloudy, wintry, but fun morning of Chem 1105 with your host, me, Dr. White. Now, first of all, by now you all should have I better practice my English more. You all should have received an individual email with your points for each answer on test number 4. By the way, you guys did really good. Thank you, thank you, thank you. Makes me happy to see students succeed. Uh, in a little while, I'll be going through the answers for test number 4. But first, you also should have received the following email. Thumbs up, people. Do you see final exam information on your screen? Thank you, Ruben. All right, a week from today, Monday, 12/13/21, I'll be giving a comprehensive 1105 final exam online during our Zoom meeting. You'll be able to download the password protected file for the final exam, whichever version you're using, on the that Sunday before. On Monday, a week from today, on the 13th at 10 a.m. or a couple of minutes before probably, I will send out emails with the password for the version of the final exam you should take. By the way, I apologize for the mess up on test 4 for, I think it was the Decay version. I messed up. Must have been because of my eye surgery. My mind was elsewhere. I apologize. Won't happen for the final. Trust me, it won't. But you'll have until noon, 12 p.m. to finish the final exam. Upload your final exam answers to the assignment area Blackboard. Realistically, the way I write the 1105 final, when I've done it face-to-face, most students are done within about 60 minutes, give or take 5 or 10 minutes. When we're face-to-face, you have an hour and 50 minutes, almost 2 hours, hour and 50 minutes to take it. Like I said, most students are done within about an hour or so. All right, the final exam will cover all material in this semester of 1105. The final exam has 27 problems, 8 pages. Some of the problems are multiple part. There'll be 5 multiple choice questions. One of the things I did this weekend was write it. Because every semester I teach, I rewrite all my tests and final. Now, from test 1, there'll be 16 points. Test 2, 44. That's why so much, because that deals with moles, and that's an important aspect of chemistry and balanced chemical equations. And test 3 will have 29 points, test 4, 21. I have hidden in here some of the new material. I have a few points too. It adds up to 110. Therefore, there's 10 bonus points. Now, a week from today will be finals week, and we will not have our regular Zoom meeting or any Zoom meetings that week. You will take the final at 10 a.m. The best way to study and do good on the final is A, show up to class this week, because I'll be doing a review today, tomorrow, and Wednesday and Friday. I'll review the whole semester. And students who do well in my class say that review has helped them. And I'll be doing it this semester. Oh, by the way, thank you, Dr. Cabin, my eye surgeon. Things are going real good. Remember a week ago, I had cataract surgery in this eye. Things are going better than I could have wished for. Thank you. But anyways, the other best way to study for the final is use your hourly exams as practice problems. Hold on, blueberry tea. Oh, that's so good from the Republica tea. But anyways, use your hourly exams as practice problems. Will I put the same problems on the final? No. However, will I put similar ones? Of course. Go back and look at your hourly exams and my practice problems. They've been similar. Also, you can use the practice problems too. I highly recommend a lot of you go back and practice test number 2 because that's where you had a lot of problems. And if you don't have the answers for test number 2, go back and look at the chapters for test number 2 and do those problem sets. Because a lot of the points on the final exam, 44 out of 110, are from test number 2 material. Now, one of the things I will say, and I'll mention it later Friday, generally, if the final's on Monday and I have another class, I have a final on Monday, I'll generally have the scores in Blackboard and also in the official My Access or whatever they call it, it's COD, the grading system. Actually, we don't use that anymore, the way we put it in. But anyways, that will be done, I guarantee, by Friday, 5 p.m., probably a lot earlier, but I know for sure it'll be done by then. I will not send out individual point totals. I never do that. I never hand back a final during the semester face-to-face, so I'm not going to hand back answers. Do you have any questions about your grades? Go through the official channels through the dean if you contest a grade. Now, let's go through test number 4 answers. I'll be cutting this out of the video. If you missed this, please feel free always to come to my office hours on Zoom. Now, if you go to look in your in Blackboard, you'll see I now have your test total. And tomorrow, I didn't get it prepared. I didn't have time today or over the weekend. I will go through tomorrow how many points you need to get the grade you want in this class on the final, how many points you need on the final to get an A, B, C, or whatever. But it's predicate. The reason why I'm not doing it now is I've thought about it, and a lot of you haven't added in the labs. And the way I normally talk about it is that assuming students have added in all their labs, which a number of you haven't. Everybody know what this means? If not, see me after class. But anyways, don't forget the amnesty program. I think it's till tomorrow evening to hand in any past labs, 8 through up to now. And don't forget, the last lab is due tomorrow. Hand in your labs. If you need help with labs, see me office hour tonight. And tomorrow I'll stay late after our review because we're not going to have a lab, but I will do a review to help you out if you need help. Any questions? All right, a couple of surprises for you. Hold on, I haven't used this in a while. Some surprises tomorrow. I will be cutting out a video, but I'm going to take you on a tour of a chemical plant that I worked in. And most Americans, most people never see the inside of a chemical plant. It's an exciting place to be. And I think probably Friday. What I will do, and tomorrow I'll also talk about how many points you need on the final to get the grade you want. On Friday, I'll end a little early lecture, and then I'll do something I started doing a couple of years ago, and that is I will give you some important points or skills how to interview successfully. I have worked for a number of chemical companies at very high levels, and at my level, I usually get interviewed with the CEO or president of the company and other high people. I've also hired people, so I know what I'm looking for when I interview people. Most people don't have a clue how to interview well. And since I started teaching this, I've gotten feedback from students. It's helped them, A, get into schools they want to get into, like University of Illinois, Chicago, and Champaign, like UICC, nursing. And it's also helped them get jobs where the employers realize, wow, this person is much better than everybody else. Why? Because they know how to interview. I'll do that Friday. That I really will cut out of the video. All right, what I like to do now, even though it was covered, first of all, I got to close some stuff. All right, success. I found what I was looking for. All right, you should have covered the stuff on nuclear radiation. I have a couple points on the final, but things I want you to know. So, hint, things I want you to know. The first thing is half-life of a radioisotope or something that's radioactive. And what you should know is the rate of radioactive decay. It's called the half-life, otherwise known as T1 half. This is the amount of time required for 1/2 of any given quantity of a radioactive substance to undergo decay. And what does that mean? Hopefully you all see the whiteboard. You know something, let me rewrite this. Sorry about this. It rarely happens, but I like the way that was. All right, that looks better. Thumbs up, people. Do you see my whiteboard? Thank you. All right, let's go through this. If you have 48 grams of compound Z, original name, with a half-life of 3 days, then how much compound Z will you have after 6 days? Now you can go online and find a very complex formula to figure this out. But if this is an even number, or this goes into the number of days, the half-life after, the easiest way is you start out with 48 grams of Z. It has a half-life of 3 days. So after 3 days, you'll have half of this, which is 24 grams. But you want 6 days. So 3 more days, total of 6. Again, you'll have half of this, which will be 12 grams. And that's your answer. And that's how you do it. Now, if I were to put this on the final, I'll do it so you can set it up and do something this way. Now, one of the questions is, why is this important to know about? Well, let's take a look. I thought this would have key ones. Hold on one second. Now, everybody see on your screen the half-life of uranium? Now, uranium-238 is 4.5 billion. That's billion years. Other isotopes are about, 700 million years. Even 234 is 25,000 years. So if you have a 2,000 pounds, a ton of uranium, let's say 234, and you store it, after 25,000 years, you'll only have 1,000 pounds or half a ton of radioactive uranium. The rest has decayed. Well, what does that mean? That means all the nuclear waste, and some of it is plutonium, is going to be around here for a long, long time. And the question is, how do you store it safely? And that's a good question. Now, a number of years ago, I guess one day, about 2002, and started, I forgot when they started building it. People in the federal government decided, let's build a national repository for all nuclear waste and say a place to store it. And somehow they decided this place about 100 miles outside of Las Vegas. And this was called the Yucca Mountain Nuclear Waste Repository. I forgot how many billions they wasted there, because they built this big cavern in the mountain, and then they developed some special containers to store the nuclear waste in. They had to be stable for thousands of years. Well, they did some tests, put some stuff in there, stored it. After about 2 or 3 years, those containers, which were supposed to last for thousands of years, started leaking. Not good. That thing whole was scrap. So that's one thing you should know. Now, the other thing I'd like to talk about is there's two types of decay or way of getting energy from nuclear isotopes or radioactive isotopes. And, oh, it's time for Dr. White to be subtle. Now, the first type is called nuclear fission. And nuclear fission, you should know, is the process which a large nucleus, something that's radioactive, splits into two smaller nuclei. That's the new compounds form. And when this happens, you release a large amount of energy. And you should know an example of nuclear fission is nuclear reactors. And those reactors make energy, heat, that heat up water to make steam, that drive turbines, things that turn around, that make electricity. And that's how nuclear reactions are used to make electricity. The problem with that is, what do you do with the waste afterward? Good question. Next, the other type of nuclear reaction that provides energy is called nuclear fusion. And nuclear fusion is the process in which small nuclei are slammed together under great energy or forces to make larger ones. And where do you find nuclear fusion? Our sun. Our sun is a nuclear reaction going on, or lots of them. And in the sun, you have hydrogen molecules coming together, or atoms really, hydrogen atoms, to make, hold on. Hydrogen atoms come together and make helium. And when that happens, it gives off a tremendous amount of energy. All you have to think about is how many millions of miles we are from the sun, and it helps keep our planet warm. So you should know nuclear fission, large nuclei going, or large elements going to smaller ones, an example nuclear reactor, and nuclear fusion, to small elements coming together, hydrogen, to make larger one. And what's the example? The sun. Now, how do you remember these? The way I do it is, think of the sun, the U here is the U in fusion, and that tells you. Now, the first nuclear bomb dropped on Nagasaki was a nuclear fission using uranium, I believe. The second one was a nuclear fusion, was the second nuclear bomb, Nagasaki, or actually the first one was Hiroshima, the second one was Nagasaki, and that had tremendous amount. And that's why they call them fusion bombs or H bombs, which I don't want to think about anymore. You should know that. There'll be a couple of points on those type of information on the final exam. Speaking about final exam, I'd highly recommend that you go to the lecture section of Blackboard, and you'll see important information file, final exam, and these will be provided to you on the last page of the final exam, where I have conversion of the temperature scales. I have 1 mole of an element equals Avogadro's number, 1 mole of a compound equals Avogadro's number of molecules of that, 1 mole of an element equals atomic weight, 1 mole of a compound equals the molecular weight of that compound. One molecular weight of the compound equals the sum of all atomic weights. Now here I have mass calculations for reaction. Those are the 3 steps you need to go from grams of one compound to grams of another. Don't tell anybody, but on the final exam, you should know how to balance chemical equations. Yep, that's why it never lies. And on the final exam, you should know how to do the 3-step process for solving. If I have so many grams of this compound in this chemical reaction, how many grams of this product will I make? Or if I mean to make so many grams of this product, how many grams of the starting material do I need to use? Know that. It's on test 2, and I said you should know that back then, and I'm saying it again. Molarity, you should know molarity. Boyle's law, you should know the ideal gas law. Hint, hint, you should know the ideal gas law. And the stuff we just went through on pH, and I don't have here, but don't forget the organic. And that's how things you should know for the final exam. Any questions? Everybody, quick thing. Did I talk about capsaicin in here? And the dumbest thing, one of the dumbest things I've ever done in my life? If I have, give me a thumbs up. All right, I'm going to talk about it now. Now, one of the dumbest things I've ever done in my life, but luckily I know organic chemistry and like dissolves like. One of the best places to get spices online, and they're located in Evanston. They have a store in Chicago, is the Spice House. I've been buying from them for many years. When I've gone to their store in Evanston at times, I've seen some of the best chefs in Chicago there. Now, a number of years ago, they started selling ground habanero chilies. This stuff is awesome. This stuff is dangerous. And I bought, the first time I bought a bottle of it, and buy it by the jar so you don't have to transfer it. And here's the dumb thing I did. I came home, opened it up. I wonder how hot it is. I went like this a little bit. I went like that. And as soon as I did that, and the tongue came in my mouth, my tongue said pain. My lips inside my mouth said pain. I was in some of the worst pain I've ever been in from the habanero peppers. Now, the molecule that does that is called capsaicin, and different peppers have different amounts. And what did I do? Well, capsaicin I knew was nonpolar. I also know like dissolves like. So water isn't going to do anything. And I know that vegetable oil and mayonnaise, which is half vegetable oil, are non-polar to a good part. So I opened my refrigerator, had a spoon nearby, took some mayonnaise, swished it around my mouth, spit it out in the sink, which I was in my kitchen, did it a second time, took it all out. And how does that work? Like dissolves like, the mayonnaise, the fat in there, the oil takes it out. Now, if you ever go to places where they serve super hot buffalo wings, they always have a dipping sauce with the celery. And that dipping sauce has a lot of oil or fat in it. That's how it gets it out of your mouth or takes the sting out of your lips and everything. Or if you've ever been at a restaurant, somebody eats something hot, they'll bring out some milk. And the milk also has a lot of, besides water, protein and fat in it, which are non-polar. So if you ever do something stupid with capsaicin, hot peppers, vegetable oil, no, I wasn't going to do shots of vegetable oil because the mayonnaise was just quicker in my mind. Or the other thing that will do it is butter. Put some butter on bread and eat it and spit it out, or just do the whole butter. And that's that. With that, oh no, I'm out of time. I'll see you tomorrow. Remember, tomorrow I'll talk about how many points you need to get on the final to get the grade you want. And tomorrow I will be starting my review for a whole semester. It's important, show up. With that, I'll say, gang gesund, goodbye. And don't forget, I have office hours tonight from 5 to 6:15 on Zoom. Auf Wiedersehen.